Assalamualaikum warahmatullahi wabarakatuh, and hi, we are from group 4. We want to present to you about the intrinsic and distortion coefficient parameters determination from smartphone. So this is our members, which is for the first one is Muhammad Azwarafi bin Ardani, second one is Nur Aiman Alimi bin Nurizan, and last but not least is Ahmad Tajuddin bin Zulkifli. Hi, my name is Muhammad Azwarafi bin Ardani, matrix number D100166. Okay, now I will show you how to calibrate the image while using the MATLAB. So first thing first, we need to put all the image in the file of the calibration tools for the MATLAB. For example, I just put this first image vision 1 and followed by the vision 2 until the vision 10. So after you put this image in this file of the toolbox calibration, so we need to add parts in the MATLAB. So how to add parts? So we click this file button and then we can see the toolbox calibration and we select folder. So here has 10 of the image that we just put before that in the calibration file. So after that, what we need to use is we need to write the calibration calib_GUI command. So as you can see here, there's the toolbox of the GUI display will show here. So we need to choose the standard and then we need to change the image name. So base name camera calibration image. So what we need to change, which is I will put in this case the vision, and then the format of the image is the JPG. So JPG stands for J. So I just type J. Okay, when we done, so this calibration image will pop up all my image that I just put before that. Okay, after that we need to extract the grid corners for the image. So as you can see here, the number of image to process, so all image we just press enter. For the random of the window, we just set for the default, which is the 5x5. So we just press the enter and then enter again. So we need to select the 4 point. Okay, after that here we need 25, which is in the equation we need the 25 mm. We are set for the y direction also 25 mm, and then we press on next. Okay, next we continue with the figure number 2. And after I finish with the extract every corner, so it will pop up the done command. Then next we go to the calibration. So here this is for intrinsic calibration. So the focal length will show the value of this coefficient, and this is the principal point, which is the center point of the image, and the value of the distortion of coefficient for this vision image after we calibrate. After that, we go to the show and extrinsics, and as you can see here, this is our camera and this is the image. So this is the view from the static image, meanwhile this is the position of the camera. And last but not least, after we calibrate this coefficient of the parameters, so we need to undistort the image, and then the command will show the do you want to undistort all the calibration image. So we just press enter and the MATLAB will program automatically until the image number 10. And after we see the done, so we can open back the document and we can see this is the distorted of the image. So this is the vision number 1, which is the image after we distort, and this is the image before we distortion. So here the comparison for the image number 3, this is visual image number 3, and this is the before distortion. So I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aiman Alimi bin Nurizan. So today I would like to present assignment 1 for Vision and System. So first of all, we need to open the MATLAB. So for this assignment, I'm using iPhone 11 camera to capture all the images. First step, we need to open or browse the folder that contains the Calip toolbox. So in this case, I'm place this toolbox Calip under this folder, and then we need to make sure that all the captured images are in the folder. Okay, then we can run the command calip underscore UI. Then we show this interface. So we need to click on the standard, and then we need to load all the images. And then to make sure that this MATLAB can find our images, we need to type the head uh, headline for the images, which is in my case the headline is photo. And then the format of the images is in JPG, so I need to type JPG. Then we execute all the images and we found all 10 images, right? And then for the next step, we need to extract the grid corner for all the images, right? And we just enter this, right? And then we need to plot 4 points for each image. And then it will ask for the size of the square or checker box. So in this assignment, we use 25mm and 25mm. So we need to do the same step for all the images. Just plot all the images. And then we're done extracting all the image. And then the next step is we calibrate all the image. And then we will show the intrinsic value for the calibration result, which are the focal length, principal point, and the skew, distortion, and pixel error. So here is the parameter after initialization, and the bottom one is the result after optimization. So you can see the difference between both of it. And then we can show the intrinsic. So this plotted the position of the images from the camera. So we can see each of the position of the image. And we also can see the position of the camera if the image are in static position. So you see the extracted from different point. After that, we also can find analyze the error, right? So the reprojection error in pixel can be seen. We can also be undistorted image, right? I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Tajuddin Music Kifli. My metric number is DE190207. So today I will present to you about how to determine the intrinsic and distortion coefficient by using the camera calibration by using MATLAB. So here I already insert the image samples captured by using my phone, which is ROG Phone 1. So here I already take 10 pictures and put it in these files and set it into image 1 until image 10. So first of all, we need to type the calib underscore GUI. It will show the camera calibration toolbox, and we will pick the standard. So first of all, we need to click at the image name. Since we set the name of the image is image 1 until 10, so we put it image and enter. Since the image is GPG format, then we type J, and it will show the all the images that have taken in this. Then after that, we need to extract the grid by using the corners. Then we click at the every corner of this checker box like this. Then it will shows the coordinate of the y and x axis. Each of the size of the squares is 25 millimeter of y and x. So it will shows like this. We need to make it to all the images. After we done with the extract the grid, then we need to calibrate the images. Then it will shows the focal length, principal point, skew, distortion, and pixel error. These parameters is the intrinsic parameter. Then we need to get the extrinsic. Then we need to shows extrinsic parameter. Then it will shows like this. There are two views, which is one is the camera center. This is the camera, and this is the object or work that have been taken by the camera. It will shows the position and coordinate of the object that have been captured by camera. Then the second view is the work center view. So it shows the position of the camera to all the images that have been taken. And the last one, we need to undistort image by click this undistort image at the toolbox. You just need to click enter, and it will save undistort image in the file. So here we can see that all this is the undistort image from the MATLAB. So we can see here, this is all of this undistort image. So that's all from me. Thank you.
Okay, next we take a look for the intrinsic and distortion coefficient parameter of each member's smartphone. We have three models for the smartphone, which is iPhone 13, iPhone 11, and ROG Phone 1. So this is the comparison for the parameter. So as you can see here, for the iPhone 13, the focal length is 1187.66316. Meanwhile, for the iPhone 11, 999.81033. Last but not least, for the phone ROG, which is 915.57510. And also the difference between distortion of the coefficient, which is for the iPhone 11, the value is a negative 1.31, 1.68, 0.06, 0.04, and 0. For the iPhone 11 is 0.089, negative 0.464, 0.0005, 0.00367 and 0. Last but not least, for the ROG phone, which is 0.026, negative 0.071, negative 0.01025, negative 0.07 and 0. That's all from us. Thank you.